Okay, let's unpack this. Um, if you've been even remotely tuned into the tech world lately, there's one name that just keeps popping up, right?
Hmm.
It's powering, well, everything, from your games to the most complex AI systems out there.
You know who we mean.
We're talking, of course, about NVIDIA, and specifically their recent GTC Paris keynote at VivaTech 2025.
Yeah, that was quite something. A real whirlwind.
It really was, just packed with announcements that honestly could fundamentally reshape industries.
Absolutely.
So our mission today, for you listening, is to cut through all the buzzwords, the technical jargon.
Yeah, get to the core of it.
Exactly. Give you a clear, concise, and hopefully really informative look at what NVIDIA actually unveiled.
Think of it like your shortcut, your way to get up to speed on the real cutting edge of AI and computing.
Precisely. So where did we start? What sources are we digging into?
Well, we've gone deep into the transcript of NVIDIA CEO Jensen Huang's keynote itself, and we've also got some supplemental notes, materials that help clarify some of the really key announcements.
Good, good. Context is key.
It really is. And this stuff is rich with insights. It covers everything from brand new hardware to the basic philosophy of how intelligence is, well, how it's made now.
Made, not just processed.
That's the fascinating part, isn't it? How these advancements aren't just, small steps. They're not just incremental.
Yeah.
They feel like foundational shifts. They're redefining what computing even means, transforming it into a generator of tokens.
Tokens. The building blocks of AI.
The very building blocks, yeah.
Wow. Okay, that's a profound way to kick things off. The idea that intelligence is actually being made by these tokens.
Mm-hmm.
It really forces you to sort of reevaluate how we think about computers, doesn't it?
It changes the whole paradigm.
Yeah.
The foundational shift, accelerated computing and beyond.
So let's start maybe with NVIDIA's origin story, because I think it frames everything they're doing now.
Good idea.
Their ambition from the start was huge, wasn't it? To create a new computing platform.
Yeah, one designed to do what, quote, normal computers cannot. That was the goal.
And that ambition led to what they call accelerated computing. Can you break that down a bit? It's not just a faster chip, right?
No, not at all. It's much more fundamental. It's about completely reformulating algorithms.
Reformulating? How so?
Well, imagine you have a massive complex task. Instead of one thing doing it step by step, you redesign the task so thousands of smaller units can work on pieces of it all at the same time, in parallel.
Okay, extreme parallelism.
Exactly. But here's the catch. Doing that reformulation, it's incredibly hard, really complex programming.
Right. So how do they make it usable?
That's where their software libraries come in. Things like the CUX suite.
Ah, CUD. Heard of that.
Yeah. These libraries basically provide the tools, the building blocks, to make that difficult parallel programming accessible to developers.
So the libraries unlock the hardware's potential?
Precisely. And each library opens up opportunities for developers, for partners, for whole industries.
Okay, so give us some examples. What kind of libraries are we talking about?
Oh, there are loads. Let's take Calitho. Jensen called it maybe the single most important application in semiconductor design today.
Wow. Why?
Because companies like TSMC and Samsung use it before they even make the chips.
Before.
Yeah. It runs this thing called an inverse physics algorithm. It basically works backward from the chip design to figure out exactly how to manufacture it down to the tiniest details.
That's incredible. What else?
Then there's QOpt. They recently open sourced this one, which is exciting.
Okay.
It's all about accelerating decision-making. Think optimizing problems with millions of variables, millions of constraints.
Like the traveling salesperson problem, but on steroids.
Exactly. But on a scale that's just, hard to fathom, solved incredibly fast.
Huge for logistics, supply chains.
Absolutely. And then you've got Warp. It's a Python framework for geometry and physics solvers, crucial for simulations.
Simulations are everywhere now.
They are. And for data science, there's QDF and QML. These speed up work on structured data, think Spark databases and classical machine learning like scikit-learn.
And the key thing there.
The key thing is 0 lines of code change needed. Huge win for developers already using those tools.
That makes adoption way easier.
Definitely. Then there's CodeDNN. Jensen thinks this might be the single most important library they've ever created.
Why that one specifically?
Because it accelerates the absolute core functions, the primitives, of deep neural networks. It's the engine for deep learning, basically.
Okay, the foundational layer.
Right. And now there's a brand new one, Dynamo. This one's designed for orchestrating really complex inference workloads across an entire AI factory.
An AI factory, that
Yeah.
phrasing again. So Dynamo is like the traffic controller for AI computations.
That's a great analogy. Yeah, making sure everything runs smoothly across a huge distributed system.
Got it. Any others that stood out?
Well, yeah, there are specialized ones like Q-covariance and Q-tensor. They're for neural nets that need to understand geometry. Think proteins, molecules.
Right, like drug discovery.
Exactly. And also for things like 6G wireless, using frameworks like Ariel and Siana. Then there's Earth 2.
Earth 2. Sounds epic.
It is. It's a simulation environment for weather and climate models. Kilometer scale resolution. Incredibly high detail.
Wow. For climate change research, presumably.
Big time. And in medicine, you have MONAI for medical imaging and Parabricks for genomics analysis, speeding up DNA sequencing massively.
So healthcare is a big focus, too.
Huge. And let's not forget QP numeric for speeding up standard tools like NumPy and SciPy.
Okay, that's a lot of libraries.
And that's just scratching the surface. He mentioned there are over 400 others.
400.
Yeah. Each one designed to accelerate a specific domain, a specific type of problem. It's like they've built a specialized toolkit for almost everything.
That's an ecosystem, not just a product line.
Yeah.
But you mentioned something earlier that sounded even more sci-fi. CDAQ. What's that about?
Right, CDAQ. This takes us into quantum computing. Or maybe more accurately, quantum classical computing.
Quantum classical.
Yeah, using GPUs alongside quantum processors. See, we're at a really interesting point with quantum.
How so?
Well, think about it. The first physical qubit, that was like 30 years ago.
Okay.
Error correction algorithms, which are essential, 1995. But the first logical qubit, a stable, usable one Google, only demonstrated that in 2023.
Took a while. So a logical qubit is the real deal, not just a fragile physical one.
Exactly. It's error corrected. It's the building block you need for actual quantum computation. And the expectation now, it's kind of like a Moore's law for quantum.
Really? Doubling every couple of years?
More like 10x the logical qubits every 5 years, 100x every 10. That's the projection.
Yeah.
And they'll get better error correction, more robust, faster.
Okay, so quantum is starting to scale. How do GPUs fit in?
The vision is that future supercomputers will have QPUs, quantum processing units, connected directly to GPUs.
It's working together.
Yeah. The QPU does the quantum stuff, but the GPU handles all the heavy lifting around it. Pre-processing the data, controlling the QPU, doing the incredibly intensive error correction calculations, and then post-processing the results.
So the GPU makes the quantum part practical.
That's the idea. And NVIDIA's quantum algorithms, running on their new Grace Blackwell 200 system, the speed-up is apparently utterly incredible.
No. So NVIDIA has this two-pronged quantum strategy then.
Seems like it. First, there's Q-quantum. That uses classical computers, like GPUs, to simulate or emulate quantum computers.
So developers can work on quantum algorithms now, even without the hardware.
Exactly. It's crucial for development. And second, there's CUAQ. They're basically inventing a new version of CUD that bridges classical and quantum.
Meaning
Apps can run emulated now, and then later they can run seamlessly with actual QPUs when they're available. It creates this hybrid quantum classical accelerated platform.
very clever. Building the bridge before the other side is fully complete.
And it makes sense they're highlighting Europe here, right, with its deep science background and supercomputing heritage.
Absolutely. So bringing this all together, what does this mean for, someone listening who isn't building a supercomputer? Why should they care about Calitho or CUDQ?
Well, it means NVIDIA isn't just making faster graphics cards anymore. They are fundamentally rewriting the rules of what computers can do.
In designing chips to simulating molecules to quantum physics.
Exactly. And if you connect that to the bigger picture, it points to a future where problems we thought were completely unsolvable, really complex scientific challenges, might actually become solvable with this kind of accelerated computing.
Pushing the boundaries of discovery.
That's the potential, yeah. 2, the evolution of AI, from perception to agentic intelligence.
Okay, let's shift gears a bit to the evolution of AI itself. Jensen Huang laid out these 3 waves, which I found really helpful.
Yeah, it's a useful framework.
So the first wave, starting around 2012, maybe with AlexNet, that was all about perception, right?
Computers learning to see, hear, understand information, object recognition, speech recognition, that kind of thing.
And then the second wave, the last 5 years or so, that's generative AI.
Right. Multimodal AI.
Yeah.
taking text and making images, or learning from different kinds of data to create something new.
And he said this generative part is fundamentally vital for us to be productive.
Yeah, you can see how it's changing content creation, design, coding assistance. It boosts productivity.
But now we're entering the third wave, agentic AI. What's different here?
This is where it gets really interesting. Agentic AI is less about just perceiving or generating and more about, well, the core cycles of intelligence. Understanding, reasoning, planning a task, how to solve a problem, and then executing. That whole loop.
So it's not just answering a question, it's figuring out how to answer it, maybe breaking it down.
Exactly. Applying learned rules to new problems it hasn't seen before. Breaking down complex goals into steps. Doing research if needed. Using tools. Even working with other AIs.
Wow. That sounds much more like, well, like thinking.
That's the direction. It's moving beyond reacting to proactively solving.
And it's not just about information, is it? This wave also generates motion.
That's a key part. This third wave is about generating locomotion, the ability to walk, reach, grab, use tools physically.
So embodiment, physical interaction.
Which is basically robotics. So you have these information robots, the agents and physical robots, enabled by the same kind of AI.
And the connection back to GeForce here is pretty wild.
Isn't it? GeForce starts for graphics, brings CUD to the world.
Which AI researchers then grab onto.
Right. Enabling deep learning breakthroughs.
Yeah.
And then deep learning comes full circle and revolutionizes graphics.
Making things hyper-realistic. Which brings us to those demos they showed.
Yeah.
The factories, the robots.
Yeah, and the crucial point Jensen kept making, that was all computer simulation, not animation.
Right, he was very emphatic about that.
Photon simulation, physics simulation, particle simulation, numbers in action, as he put it. It's about realistic prediction, not just pretty pictures.
Because that realism is needed for?
For the digital twin concept,
Yeah.
because they can simulate things so fast and accurately now, the idea is that everything can be a digital twin.
Meaning you design and test everything digitally first.
Everything. Products, factories, cities. You design it, plan it, optimize it, even operate it virtually before you build anything physical.
Everything physical will be built digitally. That's a huge statement.
It's happening now. It's not just future gazing.
Okay, so connecting this back to the listener again. If AI is moving from just understanding and generating to actively reasoning and planning, what does that change for us?
It means AI shifts from being a tool you reactively use to being more of a proactive assistant, right? Something that can tackle complex, multi-step problems on its own. The whole thinking machine idea. It's not just marketing anymore. It's becoming an actual design philosophy for these systems. 3, powering the future. Blackwell and NVLink.
And that idea of a thinking machine really crystallizes when you look at the new hardware, specifically Blackwell.
Oh yeah, the scale is just hard to comprehend.
It really is. You go from, a single GeForce card years ago to this GV200 system.
Which is not a chip, it's a beast.
2.5 tons, 1.2 million parts.
Costs around $3 million per system, uses 120 kilowatts of power.
Manufactured across 150 factories, 200 tech partners.
And NVIDIA apparently poured something like $40 billion in R&D into making it happen.
And this thing, the GB200, it was explicitly designed to be a thinking machine.
That's how Jensen described it. Built to reason, plan, and flaming. This is key. Spend a lot of time talking to itself.
Talking to itself, like inner monologue.
Kind of, generating internal words, images, tokens, processing internally before giving an output, just like we do when we're thinking hard.
Okay, so architecturally, how does that work? It's not just one giant chip.
No, it's designed as one giant virtual GPU, but it's physically disaggregated, lots of components connected by super fast, efficient interconnects.
And the performance leap is massive, right, compared to Hopper.
Huge. Remember the Hopper system? 8 GPUs, dual CPU tray, cost maybe $500,000.
Yeah, the previous top-tier AI node.
That entire system's performance is now essentially replaced by one liquid-cooled Grace Blackwell node.
One node with 2 CPUs and 4 GPUs.
Yep. And it's more performant than the whole Hopper system it replaces.
That's insane progress in one generation.
Yeah.
How do they connect all those disaggregated parts to act as one?
That's the magic of NVLink. And this is where the engineering gets really clever.
Okay.
See, scaling out, just adding more computers connected by Ethernet, that's, relatively speaking, not that hard.
Right, standard data center stuff.
But scaling up, building one single, much larger computer that acts as a unified whole, that's incredibly hard.
And NVLink enables that scaling up.
Exactly. It's not just a network. Jensen called it a memory semantics interconnect, a compute fabric.
Compute fabric.
It means it connects the CPUs and GPUs directly in a way that they can share memory and data extremely quickly, almost like they're all on the same chip. Orders of magnitude faster than networking.
And the core of this is the NVLink spine.
Yes. The miracle, as he called it. It's all copper coax cable directly connecting all the NVLink chips to all the GPUs across this spine.
Allowing everything to talk to everything else.
Simultaneously, all 144 Blackwell dies across the 72 packages can communicate without bottlenecks.
And the bandwidth numbers were just staggering. I had to double check that one during the keynote.
They are mind-boggling, 130 terabytes per second, all-to-all bandwidth.
130 terabytes.
Yeah. He put it in perspective, that's more than the data rate of the peak traffic of the world's entire internet traffic on this backplane.
Wow. Okay. Shrinking the internet into 60 pounds.
That was his line. And this incredible bandwidth is why Blackwell with NVLink 72 gets that 30, 40 times more performance in just one generation.
Which just blows Moore's law out of the water.
Completely. And why do they need that kind of leap?
Because of the reasoning models. The ones talking to themselves.
Oh, exactly. Those models generate a ton more tokens than simple chatbots. They explore a different chain of thoughts or tree of thoughts. They reflect on their own answers, asking, can I do better?
That internal work requires massive computation.
Massive. It's not just about speed, it's about supporting that depth of processing.
And I liked how they tied this power directly to business outcomes, using that factory metaphor.
Yeah, the graph. X-axis is thinking speed smarter AI. Y-axis is factory output, throughput supporting more users.
And Blackwell pushes both axes up, leading to
more revenue. A smarter factory that produces more intelligence faster.
So the takeaway here isn't just new chip faster. It's a new type of computer designed for AI thinking.
Precisely. A virtual supercomputer, purpose-built. It's a huge undertaking, but the implication is clear. The future of AI demands this radical rethinking of hardware infrastructure.
Which raises the question, how will these thinking machines change computing and business as we know it?
That's the billion-dollar question, isn't it?
And the sheer engineering effort, starting from a blank silicon wafer.
Hundreds of processing steps, UV lithography, building up 200 billion transistors layer by layer.
Then attaching 32 Blackwell dies, 128 HBM stacks onto that silicon interposer.
With tiny metal traces connecting everything, then baking it, molding it, curing it.
Stress testing in ovens at 125 Celsius.
It's an insane process. Then you have automated robots placing over 10,000 components onto the main board.
Custom liquid cooling blocks, those Kenec X7 Super NICs, the Bluefield 3 DPUs.
All coming together in the compute trays. And then connected by the NVLink switch tray and those spine cables, 5,000 copper cables.
Delivering that 130 terabytes per second bandwidth across all 72 Blackwells.
The final result, a rack weighing nearly 2 tons, 1.2 million components, 2 miles of copper cable, 130 trillion transistors.
It's a monument to global collaboration, really.
And they're making 1,000 of these systems a week now.
1,000 a week. Each rack is an entire supercomputer. More powerful than the Sierra supercomputer from 2018, but using a fraction of the power.
Yeah, 100 kilowatts versus 10 megawatts, and it's just the beginning. They're also packing this tech into smaller systems like the DGX Spark and Station for your desk.
Right, bringing Blackwell down to the individual user or team level.
And that includes the new RTX Pro server, too.
Ah, yes. Tell us about that one.
It's got a completely redesigned motherboard, 8 Super NIC switches, 8 of the new Blackwell RTX Pro 6000 GPUs.
Okay, serious workstation power.
But the key selling point, according to Jensen, it's the only server in the world that runs everything the world has ever written and everything NVIDIA has ever developed.
Everything.
AI, Omniverse, RTX gaming, Windows, Linux, Kubernetes, even Crysis, he joked. It's designed to be truly universal.
Okay, that's flexibility. So again, what's the message for our listener here?
It means AI isn't just software anymore. It's becoming the fundamental infrastructure, the energy source, for the next industrial era.
Like electricity or the internet before it.
Exactly. And the implication, countries, companies, whoever invests in building these AI factories, they're likely going to gain a major competitive edge. They'll be the ones turning data into intelligence, into revenue.
Which inevitably makes you wonder how this shifts the global balance of power, economically and geopolitically.
It's a huge question for the coming years. 4. AI as infrastructure. A new industrial revolution.
And that infrastructure idea, That's where Jensen made a really profound point, didn't he?
Hmm.
About AI data centers not being data centers.
Yeah, that was a key moment. He said they aren't there just to store data or host websites in the traditional sense,
They're one job and one job only.
is to produce intelligent tokens.
So they're not storage, they're factories.
Exactly. Like a car factory or a chip fab. They are revenue-generating facilities. And his point was, whenever you build a factory, revenue grows.
That completely reframes how you think about these massive buildings full of servers.
It really does. And it elevates them. AI factories become part of a country's critical infrastructure.
Which explains why he's meeting with heads of state all over the world.
Absolutely, because leaders are realizing they need these factories for their future economic health and competitiveness.
He called it a new industrial revolution. Not lightly either.
No, he said it's genuinely profound, affecting every single industry and creating a whole new industry, the AI industry itself.
Built on this new intelligence infrastructure.
Right. And the scale they're thinking. He mentioned Stargate, that potential 1 gigawatt facility.
Housing 500,000 GPU dies just to produce intelligence.
Enormous amounts of it.
And Europe seems to be really waking up to this imperative, isn't it?
Definitely. There's a clear recognition of the need for sovereign AI infrastructure.
So we're seeing partnerships.
Lots of them. European telcos, cloud providers, supercomputing centers, all working with NVIDIA to build out AI infrastructure.
Complementing the big public clouds.
Yes, creating this indigenous-built AI infrastructure for Europe. And it's growing fast. 20 more being planned, he said. Several potential gigawatt factories.
Aiming to increase Europe's AI compute capacity by 10x.
10 times in just 2 years. That's the plan. To tackle the AI shortage and GPU shortage head on.
And NVIDIA is setting up technology centers too.
Yeah, in 7 countries across Europe for collaborative research, working with startups, upskilling local talent, UK, Germany, Italy, France, including a big partnership with Mistral AI here in France.
So it's a full ecosystem play.
Yeah.
Not just hardware, but infrastructure, partnerships, skills.
Absolutely. They're positioned as the only AI architecture available in every cloud and pretty much everywhere else besides standard by 86.
And they've reinvented the whole stack. Compute, networking, storage.
Yep. Working with partners like Cisco, Dell, NetApp, and even software development itself is changing, moving from just C programming to things like DevOps, MLOps, AI ops.
New methodologies for a new era. Which brings us back to that RTX Pro server again.
Right, embodying that universal availability, run anything, anywhere.
So the message for you, listening, AI is becoming foundational infrastructure, the engine of the next economy.
The implication is stark. Invest in these AI factories or potentially get left behind. Countries and companies need to turn data into intelligence to compete.
Which again raises that crucial question. How does this reshape global economics and power?
It's potentially transformative. AI model enhancement and universal deployment.
Okay, let's talk AI models. Things are moving incredibly fast on both the proprietary and the open source fronts, right?
At light speed, yeah. And it's amazing how close the open models are getting. Mistral, Llama, DeepSeek, they're only a few months behind and really exceptional.
And NVIDIA isn't just making its own models, it's actively working to make the open ones better.
Exactly. That's the Nemotron initiative.
What does that involve?
They take existing open models, many already built on NVIDIA tech, and they post-train them.
Using techniques like
Neural architecture search, feeding them better data, using reinforcement learning, boosting their reasoning skills, extending their context windows.
context windows so they can remember more of the conversation or document.
Much more, which is vital for enterprise use, where your data isn't usually on the public internet.
Right, you needed to understand your internal documents, your databases.
Precisely. And all these enhancements get packaged into an NVIDIA inference microservice.
Which is like a downloadable, ready-to-run AI.
Basically, yeah. A deployable API you can run anywhere, and they're showing huge benchmark improvements, often hitting the top of the leaderboard.
And they're tailoring these for different regions, too.
Yes, partnering with regional model makers across Europe to adapt models for local languages, cultures, nuances, because, as Jensen said, your data belongs to you.
That's a powerful statement. Your history, your culture, reflected in your AI, fostering sovereign AI.
It really is. And a key piece of enabling that is their partnership with Perplexity.
Ah, the reasoning search engine Jensen uses.
That's the one. The idea is to connect these enhanced regional models to Perplexity
Thus you can ask questions.
in your own language, reflecting your culture and sensibility, and get relevant answers powered by these localized models, making AI truly global and local.
Very smart. And this all ties into agentic AI being that giant step function leap.
Absolutely. Jensen basically said, look, the criticisms of early AI hallucinating, not having current info, weak reasoning, no tools, they were absolutely right.
Refreshing honesty.
Yeah. But he said those issues are being tackled now by integrating things like RAG.
Retrieval augmented generation pulling in real-time info.
Right. Reduces hallucination.
Yeah.
Plus web search, multimodal understanding, reading PDFs, websites, videos. You can even start a prompt from an image or text now.
And the food truck example really showed the power of these agents.
Didn't it? One simple prompt. Help me start a food truck in Paris.
Sounds easy.
But the agent broke it down into a multi-step plan, then called other specialized agents. Market researcher, concept designer, financial planner running simulations, operations planner, even a marketing specialist who coded a website.
All from one prompt.
All from one prompt. And that process generated 10,000 times more tokens than a simple chatbot answer.
Which is why you need Blackwell's power.
Exactly. That's the computational demand of agentic AI.
But NVIDIA isn't just building agents. They're building the platform for others to build agents.
That's the core idea, providing the framework, the tools, so companies can create their own specialized agents with specific skills.
Using things like NEMO.
Yep, NEMO reasoning LLMs, NEMO retriever for multimodal search, and this general agent blueprint called AIQ.
Plus tools for the whole life cycle.
Everything. Onboarding data, curating it, evaluating the agent, putting in guardrails, training, deployment, security, treating them almost like digital employees.
Cisco using it for security makes sense.
Yeah. And the key is that these agents aren't one giant model. They're a system of models, optimized for specific tasks, broken into smaller pieces for deployment.
Okay, so you build these amazing agents. Now, how do you deploy them everywhere? Public cloud, private cloud, on your desk. They need to talk to each other.
That's the challenge DGX Lepton is designed to solve.
Lepton, the cloud of clouds.
For one super cloud, the idea is one model architecture, one deployment. Run your models everywhere.
How does it work?
You deploy your NIMs into Lepton, and then Lepton can host and run them across AWS, Google Cloud, regional partners, wherever you need them.
And the story behind the first DGX one is amazing.
It really is. 2016, first AI supercomputer, billions spent, and nobody wanted it.
Does it run Windows? Nope.
Total confusion, until this little nonprofit called OpenAI said, we'll take one.
And Jensen personally drove it over.
Yep. Learning the lesson. If a developer reaches out and needs a DPU, the answer is yes. Foundational moment.
Incredible. So now Lepton makes deployment seamless.
That's the goal. Work in your browser, package your agent, deploy it partly locally, partly in AWS, then push it all to the cloud. And the Hugging Face integration.
One-click deployment from training to Lepton.
Exactly, making it super easy. And lots of companies are building on this platform now. SAP, Sana, DeepL, AI photo room, clinical trial platforms.
So the NIMs, Nematron models, libraries,
Yeah.
they integrate into frameworks and run anywhere. Cloud, on-prem, private cloud, DGX station.
Total flexibility, that's the vision.
Okay, connecting this to the big picture again, it feels like advanced AI is becoming radically democratized, doesn't it? Easier to access, customize, deploy, no matter where you are.
It does, which leads to the question, how will this explosion of accessible AI power impact innovation? Not just for big tech, but for startups, for individuals.
It could be a massive wave of creativity.
Could be. 6, industrial AI, digital twins, and the future of robotics.
Let's pivot now to industrial AI, very relevant for Europe, as Jensen noted.
Yeah, he paid tribute to Europe's industrial strength, even mentioning Siemens and their 1992 neural computer, Synapse One. Amazing foresight. And now Siemens' CEO is pushing to fuse that industrial power with AI.
Supercharging the company, as Jensen put it, to lead the industrial AI revolution.
Covering the whole life cycle. Design, simulation, digital twins of factories, AI operating in the factories.
End-to-end transformation. They showed that love letter video.
Right, painting the picture of the fourth industrial revolution, the age of AI.
Reimagining industry, bringing physical into virtual, planning factories, building robots, creating a collaborative workforce of humans and machines.
And it's not just a vision, right? Companies are doing this now.
Oh, yeah. BMW, Mercedes-Benz, Schaefer, the French train system, Toyota, all building digital twins of factories, plants, warehouses, and Omniverse.
And the benefits are concrete. Better planning, optimization.
Huge benefits. Design, plan, change things virtually, simulate effectiveness before you physically move heavy equipment around only to find it wasn't optimal. Great for new builds and optimizing existing ones.
And these twins have to be photorealistic and physics-based. Why is that so crucial? Especially for robot learning. Robots using photons, Omniverse generates those accurately, and they need to interact with a world that obeys the laws of physics to learn properly.
Makes sense. Simulate realistically to act realistically. They even showed a fusion reactor digital twin.
Incredibly complex simulation, impossible without AI, he said.
And now NVIDIA is building an industrial AI cloud specifically for Europe.
First one, focused on design and simulation. Virtual wind tunnels, digital factory twins, essential for safety and performance in industry.
Building on their long history here.
33 years in Europe, supporting what he estimated as a $2 trillion ecosystem through CAD, CAE, and now digital twins.
Which leads us perfectly into autonomous vehicles and robotics.
Because, as he said, everything that moves will be robotics, and cars are the obvious next big one.
And NVIDIA is playing across the board there, training computers, digital twins, the car's brain.
The whole stack. AI supercomputers for training, Omniverse for simulation, and the actual computer, OS, and AI models in the car.
With the Halo safety system at the core.
Yep, their software-defined, AI-driven stack for AVs. Functionally safe, winning awards.
And trained heavily on synthetic data from Omniverse to cover edge cases.
Exactly. You need massive, diverse data. Omniverse generates realistic synthetic data for situations too rare or dangerous to capture easily in the real world.
Plus redundancy in the system. Classical stacks, guardrails, redundant sensors, and compute.
All for safety, even if components fail. And the market opportunity is just
Gigantic. 1 billion cars, 10 trillion miles driven annually.
huge, but maybe even bigger. Humanoid robots.
The ultimate challenge.
And potentially one of the largest industries ever. 1 billion robots. Doesn't sound crazy in the long run.
But they're hard to program now, right?
Way too hard for most businesses. Only the biggest companies can afford the expertise.
So NVIDIA wants robots to learn from us.
Yeah.
Using Nemo toolkits like the AI agents.
That's the idea. Make interaction intuitive. And the Thor processor is their robotic computer.
A self-contained dev kit. A little supercomputer chip for controlling limbs.
Exactly. But the biggest hurdle for humanoids is data. Where do you get enough training data?
Omniverse again. The physics-based digital twin world.
That's the solution. They're working with Disney Research, DeepMind, building the most sophisticated physics simulation possible.
And the Greek demo showed the payoff.
Incredible, wasn't it? Learning to walk, handle objects in hundreds of thousands of Omniverse scenarios, sand, gravel, slippery floors.
Then transferring that skill to the physical world almost perfectly.
The real world just becomes the 100,001st version it's already seen, watching it jump, dance. It felt like a glimpse of the future.
Someday we'll all have one like you. Chilling and exciting.
So what does this all mean for you listening? It means the line between digital and physical is blurring fast in real, practical ways.
Everything that moves becoming intelligent, autonomous.
From cars to factory floors to maybe even robots in our homes. Which makes you ask, as robots get smarter, more human-like, how does our relationship with technology change?
What new possibilities and maybe challenges does that create?
Big questions for us all. Outro.
Wow. Okay, that was a lot to unpack. This deep dive really highlights the sheer scale and ambition of what NVIDIA is doing.
It's definitely more than just a chip company.
Right. They're building the intelligence infrastructure for a whole new industrial revolution.
And the hardware, like Blackwell, isn't just faster. It's a thinking machine, delivering these huge performance leaps.
We saw AI moving into that agentic phase, reasoning, planning, enabling real information, and physical robots.
And how crucial Omniverse and digital twins are for designing, optimizing, and training it all from factories to fusion reactors.
Plus the software and deployment side, Nemotron making open models better, Lepton making AI deployable everywhere.
Making advanced AI much more accessible.
Yeah, it's a comprehensive vision.
And if you really think about those AI factories as revenue generators, as national infrastructure,
Yeah.
it raises that provocative question. Who benefits most in this new age? Who innovates? What does it mean for global competition, for productivity, for society?
It really forces you to rethink economics, maybe even societal structures, in the face of this intelligence infrastructure.
It's a challenge beyond just the technology itself.
Well, this has certainly broadened our perspective.
Oh.
Seeing how tokens build intelligence, how hardware is being reinvented, how AI is reshaping industries, it's incredible. We
Mm.
really can't wait to see the breakthroughs you listeners might create using these innovations.
The potential is enormous.
Definitely. Join us next time on The Deep Dive, where we'll be unpacking the future of sustainable energy technologies.